live. Hi guys, welcome to my channel. So this is the sixth day of solving Leetcode live challenges. So those who are new, in this channel, I'll solve these questions live. I read the question, I haven't read this before, and I'll be reading the solution, understanding what's required. We will be building a solution that is the answer to this problem, and then we fit that solution to the constraints. So basically that is how problem solving is done, and we will explore it from the scratch. Okay, so let's jump into the screen where I share everything. So this is my notepad, and here I have already created this. I have already taken a snapshot of this problem. Now let's go ahead and read this problem. Okay, so the question is about longest square streak in an array. Okay, so there will be an array and longest square streak. So we have to decode this. What is it? Okay. So you are given an integer array nums. So you have been given an integer array that is nums. Okay. It contains integers. Perfect. A subsequence of nums is called a square streak. So notice this word subsequence. So what is a subsequence? Sequence means like if there is an array, let's say it is like this. Sequence will mean, in my opinion, it will be any random sequence. Sequence is basically sequential movement, right? So we can choose few elements, and when we write them in sequence, it would be like in ascending order or something. So in this case, it will write it like 1, 3, 4. And what a subsequence is, basically any sequence out of all the sequences possible from this array, subsequence will be one of them, right? Okay, so we call a subsequence a square streak when we call them the length of the subsequence is at least 2. Okay, so I'll write the conditions for a square streak. So it is for a subsequence, so don't get confused on that. So let me just do this here. So this is for a subsequence. So what is the first condition? It is size should be greater than equal to 2 because it is at least, so minimum 2 elements should be there. After sorting the subsequence, each element except the first element. After sorting the subsequence, so second condition says sort it, and then each element is a square of the previous number except the first element. Let's say we got this kind of subsequence and there are a few numbers here. Then accept the first element, and we know that size is minimum 2, so there will be some more numbers over here. So they are saying the accept the first element, the next element will be square of the previous number. So let's say if we have 2 over here, so the next element should be 4 square of 2, and then next element should be 16 square of 4. Now what we have to do, we will return the length of longest square streak. So this is the condition for a subsequence to be a square streak. And we have to return the length of the longest square streak in nums, right? And return -1 if there is no square streak, right? Perfect. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of remaining elements. So yeah, basically subsequence is here in this case, it will another array will be our nums array. So what they say, so you can create a subsequence by deleting some or none elements. So you need to delete some elements from here, or you won't delete some elements. So it's basically either you delete or you select. Both of them are same thing, right? So here you delete some element and the sequence which you get should be preserved, right? Likewise, what I told you here, the sequence should be the same, like 1, 3, and 4. And when you delete this, whatever is left out is your subsequence. Okay, simply put, subsequence is like basically you extract random characters, and they should, there's just one condition, they should be in the same order in which they were in the original nums. right? I don't think that would be a problem. So now let me just build a solution for this, which is pretty much straightforward. But yeah, solution is straightforward, but if it fits to constraints, that is not. So let's check out some examples for clarity. So we have been given this particular example, 4, 3, 6, 16, 8, 2, right? So if we consider this 4 here in any of our answers, so we will look for 16 as a next element. Then we look for 16 square. So no, it's not there. If we consider 3 here, then we look for 3 square, which is 9. And then we look, 9 is not there. So it means 3 is a dead end. We just we just cannot have two elements. So there is no possibility of any subsequence of 3. Then we go for 6 here. So for 6, we can explore 36. 36 is also not there. For 8, we can go for 64, which is also not there. And for 2, we can go for 4, but in this part of area, but there are no elements here. So though there is still 4, but it is in the left side. So we cannot go left side, because if we take 4, this 4, and we prepare a subsequence, it will be 4, 2. But what is the condition? Okay, so I forget this. We had to sort it as well. All right, so after that, you can sort it. You can get it like this, 2, 4. And then you just, so this will also follow the, right. Basically, you can take 4, 16, and 2, and they will follow the logic which you want. Yeah, so the thing is, if we have to sort it, and in this case, let me just write it down. Let me just iterate the test case for you, then we build the solution. So basically, does they say? What do they say? Choose the subsequence 4, 16, 2. After sorting, it becomes 2, 4, 16. They have directly jumped to the answer, right? And you see here, 2 square 4 is there, 4 square 16 is there. So it is a square streak. And what you have to return? You have to return the length. Okay, so you don't have to return elements. It can be shown that subsequence of length 4 is not a square streak. Obviously, we are not getting such numbers here. Okay, so this brings me, now we are finally building the solution. Okay, so looking at this example, what I saw here was that I'm reducing one thing here, that this sequence doesn't really matter, because at the end we are sorting it anyway. So why not I sort this entire thing beforehand, like this 2 4 8 2 4 sorry 2 3 4 6 8 16. And now I start with my own logic. Let's say if I'm considering to take 2, in that case I'll go with 4, then I'll go with 16. So here I'll directly get 16. So here I just need to progress in this direction and look for the elements which are kind of present earlier. Okay, okay, makes sense. Perfect, perfect. And then okay, so for 2 we kind of do this exploration, then we do this exploration for 3, we look for 9 in this part, to be specific. No, it doesn't matter. Actually, it doesn't matter. 9 could be either. So, okay, so 9 will be definitely here only, but in this array, it doesn't matter. If you're looking for 3, you'll just look for 9. Then you look for 9 square, which is 81. Then you look for 81 square, right? Like that, it will progress. Okay, makes sense. So why not we just so if we have already sorted, what benefit it gives to us is that we already start with smaller numbers and we just need to explore the higher numbers, right? This should be clear to you all. And when we spot 2 square, which is 4, then definitely this 4 is booked, right? Because if we try to take this 4 in any other sequence, what should be the previous element? It should be either 2, it should be only 2, right? Because the next element is the square of the first element, right? And if you consider going with this 4 alone, so obviously this will follow the same path as this, as we follow this here. So 4 16. It's better to take 2 416 rather than 416. Okay, so what the logic I built here was this. I will sort this entire array. So here it's already sorted. And then I'll start element by element. I'll put all these elements in a set, y set, because it gives me order, log, and lookup, right? If I want to look up for some number or not, right? Makes sense. So I'll start element by element. And what I'll do, this is more important. So basically I started with 2 and I'll check if 2 square is there or not in the set. Then there are two options. One is yes and other is no. So if 2 square is not there, it means like we have built only one element subsequence. So here we will just end and whatever is there with us. So here we have 2 only. So this is our subsequence. So this is an invalid subsequence. So we reject it. And if it is present over there, then we look for 2 squares square. And again, this will be your order 1 lookup. And when you see a yes, you go ahead. If no, so you are ending up with 2 and 4. So you just note the size of it and move ahead. That's the thing. Now what I want next is basically the elements which I've already explored should not be explored again in this particular array. For that I need to somehow delete 4 if I have already considered it in the when I was exploring 2, right? So first thing first, we will maintain a set of this. Now when we are iterating through elements, we need to have a flexible data structure where we can delete elements on the fly. So yeah, this is another thing. But yeah, we will think about it when we will build the full solution. But the algorithm should be clear to you. What we will do, we will sort it, sort the entire array, then element by element, we look for squares and till it goes, it's fine. And when it stops, then report a answer. This should be very much simple to everyone, right? This is the main algorithm, I guess. And then, yeah, this is the main algorithm. First step, let me write it for you. So again, I'll write it in a clean way now. So the first step is to sort, which is easy, which will take n log n time complexity because it's an array. Second operation is basically putting in the set, which is again n log n operation, doesn't really matters. And then you have third thing, which is the this element. So you have to iterate for element e of array norms, right? What you need to do, you need to check e, then e square, then e cube, sorry, e to the power 4, which is basically e square square. Then it is like e4 square, which is 8, so on until unless you stop. When you stop, you just, yeah, you just report the count to the answer, and whatever count you got during this process and whatever is the maximum count is your answer. That is pretty much straightforward. Now let's examine the time complexity of this approach. So this is n log n, this is n log n. These lookups are log n, but you should note here, right? If we do it element by element, let's say we did for, let's say all the elements are squares like they should be. In that case, when you start with 2, you will go for 4, you'll go for 16, you'll go for 256. When you start for 4, you'll go for this and this, right? But the thing is, when you go for 4, you are doing this kind of waste calculation because that has already counted in 2. So if you don't avoid this, the answer will be of n square times log n, because n square elements we are processing again and again, because this was 4 was processed twice, this was processed thrice, this was 4 times. So what we need to do, that's what I was talking about here. We need to have some flexible data structure which deletes the elements which are already processed. either you can have a data structure or you can have a skip logic defined. So basically you have a index visited index in a map, which will just keep track of whether a particular element is visited from nums during these processes. Fair enough. That's it, guys. And if it is already visited, you skip this entire process for that. And that will obviously, when we're done with two, you have computed, like taken four steps, four elements you have processed. When you come to four, you just skip. When you come to 16, you just skip because they are already marked visited, right? That's the logic. So guys, this is the logic, and I think this entire thing will be order n log n. So I'm adding them all up, right? So plus order n log n, and this step is basically n times. Okay, I could not check this. Wait. Hmm. So basically, if we are doing some kind of exploration here, it is kind of progressive counting. Okay, it's not a n square counting. So you should understand that. Basically, when I'm doing 2, 4, 16, 256, wait, not good. 2, 4, 16, 256. It's a progressive counting because when I started 2, I actually kind of deleted these nodes. So I did only order n computation over here. And the lookup was log n. So this is also n log n. So this is a big notation. So we all know the final time complexity is n log n here, and you get your answer. So I think this approach fits good for these constraints because n was 10 to the power 5 and 10 to the power 5 log n satisfies this constraint. Okay, so that's the thing, okay, guys. So let me mark the data structure which we are using here. So first we are using sorting will be done in the array given to us, which is basically a vector. Sorting is an internal method over there. And then you will need a set over here. Apart from set, you will need a visited map, basically a visited index. Right. So let's go ahead and implement this in code. Okay. So this was, I think, the simple solution, and I'm sure this will pass, but let's try it in code. It might be there like we get some errors or we get some wrong solution, but yeah, obviously at this point I'm confident for this. I'll just quickly check if you guys are there with the live stream or live stream is up or not. So guys, don't mind my recommendations, they are just random ones. Okay, so we are live and I can see this logic which I have built. Okay, so there is only one visitor, which is me. Fine, doesn't matter. Okay, so this is the entire logic which we have built. And this was, I guess, this logic building was very much simple at this case because it did not involve any kind of mm, like hiccups or something. So let me just create the data structures which we will use here. So first thing first, we just I'll just wait, ds over here, and here I'll just define a variable name which is now n, which is the size of this area because n is quite handy when we move with the solutions. And guys, this is the basically the other data structure which we need. First is set of integer, right? And wait a minute. One more thing you have to consider when you're doing a num square, it could go up to 10 to the power 10, right? So this integer won't be able to handle that, right? So this should be inside set, it should be int. It's fine, but it's better to keep long because obviously the variables will be long. And in fact, this set is safe, to be honest. But I'm doing it just for, okay, let's not do it. Set is safe because it is 10 to the power 5 only, so it is well beyond the well within the limits. So I'll just call it st. And what we need to do next, we need to just first sort these nums array, right? Why we are sorting, by the way? Uh, Wait, the syntax is like this, I guess. Yeah, guys, I'm doing coding in C++ after a very long time. So by time I'll get master these syntaxes, but our primary logic is to getting the problem correct, and then we just build the solution which fits. And when you code, this is also a serious thing. Basically, you should be aware of syntaxes and the small complexities with the language, right? But when you practice, you can learn it only through practicing. So while you practice, then you learn it. It would be in your memory for a longer time because you have some kind of attachment to that. Okay, because you have solved a problem. Okay, so we have sorted it. Now we just push these elements into the nums. So I'm using an iterator, auto iterator nums, and I'll just push these elements, which is an insert method, to the set. That's fine. Now we need to conduct this particular logic, but before that we need to have our visited set. So let's create a visited set over here. So there are n elements. So this is also zero mapped only. So I created this here, and I need to initialize this. Let's use a vector, which is easier to initialize in one line. So I just created a vector which is visited vector. There are n elements and all of them are 0. So initially they are not visited. Now I now move to the loop. So here I am just doing it. So I equals to 0, I is less than n. I'm just doing an iterator over here, nothing fancy. So first thing first, we have the visited set. So if visited of particular index is equal to 1, then we can just skip this step, right? And now here comes the lookup part. So here you need a long variable which will store the squares. So we start with I'll call this variable t. We start with the element itself, which is nums of I, right? And first, so this will be obviously there in the set we have. Now we have the answer over here, which is initially defined to -1 because initially we have not encountered any streak square subsequence. A subsequence which is a square streak, right? Longest square streak. Because obviously we'll be looking up here. So now we need to also track what the length of the lookup, how far we have progressed. So clearly there is the first element inside the lookup scene. So we will just have len variable which is set to 1, which will increase as we progress. Now we have this while loop. While what is the condition of this loop to move forward? If n square is there in the set, we will go down. If it's not, then we just exit. So the condition is st.find t multiplied with t. Okay, so wait, this t multiplied with t will fit in this long. That's correctly like totally fine. But when we are operating a find statement on the set, it should also support checking long numbers, right? So for that case, we need to have here long can take these elements to like 10 to the power, yeah, 10 to the power 10 or 10 to the power 18 to be honest, and here we have to just consider till 10 to the power 10, right? So this is there. If we find it, it means the iterator is not returning an end iterator, right? So it's not able to end because we have found d square over there. So what we need to do here is basically len plus plus. Next thing is we need to change t. So t has been changed. And we need to mark, okay, so we need to mark the visited thing over here. Okay, this is the challenge here because um yeah, so we cannot go by indices here, guys. Very sorry for that. This should be a map, not a vector. Why I'm just telling you here. The basic logic is same, but here we had some problems. Now what we need to do over here is this. We need to insert this in map and initialize with zero value. Perfect, perfect. Zero means it's not visited. And here I'll just do MP. If it is one, then continue. Right? So this should not be MPI. This should be basically nums I. If it is visited, then continue. Otherwise, I can just mark it visited over here. I just make this MP and then I do this nums I equals to 1. Not nums I, basically it should be t square, and t has now changed to t square, so that's fine now. In fact, when we are looking up in this, we can also mark this as visited, which we call it like this nums I, no, which is fine. We can just keep it t, and t should be equal to 1 again. So t square will be within limits because this will not exceed 10 to the power 10, and so that makes this safe. And when we come out of this loop, there is one condition check. If len is greater than equal to 2, which makes it a valid subsequence. And then we do this, we do answer equals to max of answer and the len which we have, right? And in that case, we at the end return our answer variable. Cool, makes sense, right? Yeah, it was kind of short. Let me check if it is correct. Maybe I can get some error over here about the syntax. No, there was no error for that. The runtime is 3 ms, man. Is that an issue? Basically, we are continuing over here, which will ensure that it is at worst 2 times n, not n square. And this is purely login operation, which we are doing here. This is basically a complementary operation, which is basically not causing any time complexity hiccups. So basically, this is, I think, done. Let me just make a submission if I'm sure about the code. Yeah, basically this was solved very quickly. I'm still not sure if it is actually correct. So let me just check. And if it's not, then obviously we'll try our best to identify the mistakes. Mm-hmm. Mm-hmm. So yes, guys, this is correct solution. And now there is a big issue here about the runtime. So like 2% solution have this much runtime. Mine was 400 ms. And what is the time complexity? Yeah, this is n log n what we had earlier did. So I think the best solution would go with order n time. And if you guys want me to try that, you can just write in the um, YouTube comments whether I should like try attempting or try thinking about the order n approach. Solution would go with order n. Yeah, so we are streaming since 29 minutes only. Okay, guys, so I think, wait, memory also it takes, because memory wise, I know it's kind of large because of this map. If we really try to optimize this, if we don't, I'll think about it for 5 minutes maybe. So let's say if you really want to optimize it, um, All right, so how can we optimize it? So we have these array elements, right? And wait, let me just draw something. So we have these array elements, and let's say they are scattered over here. 256 exists here. And if I want to do it in kind of very much efficient manner, how can I do that? I know this that they will go till 10 to the power 5. So what if so let's say if there is 2, so what if I write all the squares in a particular this kind of arrangement? That will not be sufficient, I guess. Basically, we can go like this. We have 10 to the power 5 numbers, right? So we can, the numbers can go up till this range, right? So we can write each and every number over here. That makes sense, right? And there is some sort of linkages here. 2 is linked to 4 is linked to 16 till we go to the end of the 10 to the power 5. And what we need to do is to find the maximum thing out of this. Mm-hmm. Yeah, we can definitely club these numbers too. So like I said, we will start with 1, we will start with 2, we'll start with 3, and 4 will be here only, 5 will be here. Basically all the prime numbers will stay here and their squares will come alongside them. So what you had to do, like basically the square, these all numbers are when you reduce them down, let's say you spot 16 and you just reduce them down by like 16 is the square of 4, 4 is the square of 2, it will come to 2. So this down reduction is not easy, to be honest, but if you try to do this kind of approach, then what could be done, like this. You had that array nums, okay, you have all the elements here, you just pick any one element, you try to reduce it, basically try to reduce it with this level, like if it is a perfect square, you have to be doing that, if it's a perfect square, then you just boil it down to some number, and you maintain some map which kind of stores these number frequencies, and you do a plus plus which is kind of giving you things like this. Yeah, guys, this is it about today's solution. I think n log n is fine. We can better it up to order n, but that is definitely not required for this question. So, obviously, if you guys want, we can try, but obviously, it will make this video longer, which I don't want. If I myself reduce that solution, I'll be definitely making another video and just posting it as a solution. So, the concept of live stream is basically we try to fit in these constraints and we try to make the solution better keeping in mind these constraints only. So n log n is fine for this problem, and that is it, guys. I think this was a very much short session. earlier we have like Earlier we have had sessions of 1 hour 30 minutes, like just the session before this. Okay, guys, so it was very much I enjoyed connecting with you all, and we'll meet in the next one. Bye.